Welcome to Unit 2, Polynomials. In this unit, we're going to look at two main concepts. One is expanding polynomials using the distributive property, and the other is simplifying polynomials by factoring. Let's get started with our learning targets. By the end of this lesson, you should be able to use algebra tiles to model the multiplication of two binomials. You should also be able to multiply a monomial by a polynomial, a binomial by a binomial, and a binomial by a polynomial. And using those skills, you should also be able to solve problems using multiplication of polynomials. If I have 4x all in brackets squared, that would mean 4x times 4x, and 4 times 4 is 16, x times x is x squared. Remember from our last unit, if I have a product being raised to a power, I can distribute that exponent. So that would give me 4 squared, which is 16 times x squared. In our next example, we want to simplify by combining like terms. So I have 12x and negative 5x. 12 minus 5 would be 7x. Notice that the variable stays the same. So it's like having 12 apples and you're subtracting 5 apples. Then I have 3y plus 2y. So a positive 3 plus 2 is a positive 5y. Again, I'm combining apples, 12x minus 5x, and then oranges, 3y plus 2y. And I end up with 7 apples and 5 oranges, or 7x plus 5y. For our third example, again, we're combining like terms. Pay close attention to your variables. So for the first term, I have 6x squared y, and then the next term I have 3xy squared. Those have the same variables but not the same exponents, so they are not like terms. However, 6x squared y can be combined with negative 4x squared y. So 6 take away 4 is 2x squared y. And then I have negative 3xy squared and positive 2xy squared. Negative 3 plus 2 is negative 1, so I'm going to have negative xy squared. When we're working with polynomials, a very common mistake is to not pay attention to the symbols in front of the numbers. Often we'll have 6x squared y, we'll see that we're subtracting 4, but in the next step, we'll see the 3xy squared, but we will miss the negative. And often people will just go 3 plus 2 and write 5. It's always important to pay attention to the symbol in front of the number because that's telling us whether that term is positive or negative. All right, moving on to multiplying polynomials using algebra tiles, I'm just going to switch to an interactive screen here. Now, before we get started with our algebra tiles, it's important that we know what the tiles represent. So first of all, we have a rectangle representing a positive x. That's a shaded rectangle. An unshaded rectangle would be negative x. When I take x times x or multiply x times x, I'm going to get a square, which is x squared. Unshaded would be negative x squared. And then the little squares are positive and negative 1. In this legend, I'm using shaded as positive, unshaded as negative. It's important to know that in other resources, other textbooks, other websites, you might notice that the shaded is negative and the unshaded is positive. It is perfectly acceptable to do it either way. So when you're working on an assignment, it's important that you indicate your legend. And that's as simple as just drawing a little square or rectangle, whatever. And if it is positive, then write positive. It's negative, write negative. And again, if you want to reverse that and make the shaded negative and the unshaded positive, totally fine. Now, as we get into multiplying with algebra tiles, essentially what we're doing is we're creating an area model. Remember that area of a rectangle is length times width. So I'm just going to have my x plus 2 as my length and my x plus 2 as my width, or vice versa. The first thing I'm going to do is set up that length and width. So x plus 2 would give me x and a positive 2. And then for the other side, I'm going to have x plus 1. So that's going to be x and a positive 1. Now, when I'm multiplying them, I'm just multiplying individual pieces together. So x times x is x squared. X times 1 is positive 1x. Positive 1 times x, again, is going to be x. X times 1 is x. And then I have 1 times 1 is positive 1. And 1 times 1 is positive 1. So if I represent these expressions algebraically, I have x plus 1 times x plus 2. Those would be my factors. And my product would be x squared plus 3x plus 2. Writing that as an expression, I would have x plus 1 times x plus 2 equals x squared plus 3x plus 2. Let's take a look at one more example. So I have x minus 2 times x minus 1. Setting up my factors, I'll have x minus 2 and then x minus 1. When I multiply again, x times x will give me x squared. Positive 1x times negative 1x will give me a negative. Again, x times negative 1 is negative 1x. Negative 1 times positive x is negative x. And negative 1 times negative 1 is positive 1. Again, notice that I'm filling in that rectangle. So my factors would be x minus 2 and x minus 1. X minus 2 times x minus 1. And that would give me a product of positive x squared minus 3x plus 2. Now in this case, my x's were all the same sign. There are going to be some times where you've got some positive and negative, so they will cancel each other out. Notice that if I have a positive 1 and a negative 1, that becomes a 0 relationship because a positive plus a negative becomes 0. Now I'd like you to try these next two examples on your own. So pause the video, write out your factors and your product and then your algebraic statement, and come back and check your work. Let's take a look at what you have. So far I've only indicated the factors. We're going to work through the products here. So I have 2x plus 1 and then a positive x and 3 negatives. When I multiply those out, I'm going to have x times x gives me x squared. Now something that I notice as students start working through algebra tiles when we're drawing them out is they don't line up their sides. And so what ends up happening is I will have sort of all of my factors written here, my factors written here, but my product will fit into this little tiny space. And so not everything lines up and we tend to make little mistakes. So it's always important that we are being very methodical as we write this out. So again, we had x times x is x squared. So you'll notice that the length of this side is the same as the length of this factor. The length of this side is the same as the length of that factor. Again, I have x times x gives me another x squared. And then x times 1 is a positive x. On the next row here, I have a positive x times a negative x, so that's going to be negative x. Another negative x. And then negative 1 times positive 1 is negative 1. Again, I'm going to have the same thing down here. And you'll notice that my drawings are not perfect. I make lots of mistakes. I don't even have them quite the same size, but I try as best as I can to have everything lined up. So notice now I have 2x plus 1 and then x minus 3. For my algebraic statement, I could write 2x plus 1 times x minus 3 gives me 2x squared. We have a positive 1 and 6 negatives, so these two will cancel each other out. That's going to leave me with negative 5x, and then I have negative 3. For our second example, I have 3x plus 1 and x minus 2. Multiplying these out will give me x squared and another x squared, a third x squared, and then a positive x. And then in the next row, positive x times negative gives me a negative x, another negative x, and so on. Some people will like to write everything out and then just go back and do the shading as they need. Notice again, negative times positive is negative. So writing my algebraic statement, I would have 3x plus 1 times x minus 2 leaves me with 3x squared. Two of these will cancel out, so that's going to leave me with negative 5x and negative 2. Algebra tiles are simply a visual aid that will help to model what we're doing. Ultimately, I'd like you to be able to move beyond that and work towards doing this completely algebraically, but this is definitely a good visual to help see how everything comes together. Now, before we move on to multiplying each of these types of polynomials, let's get familiar with some of the terminology. So first of all, a term. A term has both coefficients and variables joined by multiplication. If something has one term, it's called a monomial. So 4xy, 5m squared times n all put to the exponent of 3, -7, those are all monomials. A binomial will have two terms. Notice that it's two terms separated by a plus or minus sign. So 3x plus 4, -9p squared minus 2q, 5a minus b. A trinomial will have three terms. X squared plus 5x plus 6, 5m squared minus 3mn plus n squared. And then a polynomial is anything that has more than that. So monomials, binomials, trinomials all fall under polynomials, but anything that has more than three terms we typically just refer to as a polynomial. Now looking at the term itself, 3x squared, 3 would be my coefficient, x would be my variable, and 2 would be my exponent. 2x squared minus 3x plus 4 is a trinomial. Notice that the 2 is a coefficient, the -3 is a coefficient, the 4 is a constant. Now, when I'm writing a polynomial, I will typically write it in algebraic order. That means I'm writing it from the highest degree to the lowest degree. Highest degree is referring to the highest exponent. So here I have 2x squared. That has a higher exponent than 3x, which would have an exponent of 1. When I put this polynomial in algebraic order, the coefficient that's in front of that highest degree variable would be referred to as my leading coefficient. Now, as we start to learn more about functions in a later unit, and definitely more so in grade 11 and 12, you'll start to see what the purpose of that leading coefficient is when we start graphing functions. Now, the last piece that I want to point out is our positive 4. So we have 2x squared minus 3x plus 4. The positive 4 is referred to as our constant. And it's called our constant because it always stays the same. You'll notice that when I have an x squared or an x, the value of that term will change depending on what I put in as my value for x. The positive 4 doesn't have a variable with it. It actually does. It's x to the 0, but x to the 0 is just a value of 1, so it really doesn't change anything. So again, if there's no variable with the number, it's going to stay the same because there's nothing to change it or to vary it, so it's referred to as our constant. Once again, when we get further into understanding of functions in later units and in later courses, you'll see the connection between the constant and our graphs. As I said at the start of this video, this unit really covers two major concepts. One is expanding and one is factoring. So everything we do with regards to polynomial operations is going to involve expanding. That's what we're working with today. So multiplying, and our final expression will have positives and negatives in it. Factoring is taking a polynomial that's already expanded and simplifying it down using factoring, and our final expression will be all multiplication. So we're going to get started with multiplying monomials by monomials. This is something that should be familiar to you as we already did this in a previous unit. So we have 4 times 3x squared, 12, and x squared. 3x times 6x, 3 times 6 is 18, x times x is x squared. 2b times 3a squared b, 2 times 3 is 6, a squared, and b times b is b squared. Notice again, I'm writing this in algebraic order, so I'll typically write that in alphabetic order. Now for D, it's really important that we pay attention to our exponents. Remember that when we're expanding any polynomials, we have to pay attention to order of operations, starting with brackets, exponents, and so on. For this example, we have a squared. That means we need to bring that in or deal with that before we can move any further. One way is to write 2x times 3x times 3x times 4x, or again, we can just bring those exponents in. So we have 2x times 3 squared is 9, so 9x squared, and then 4x. So 9 times 4 is 36, times 2 is 72, and then x times x squared times x, so x to the 1 times x squared times x to the 1 gives me x to the 4th. And just like we learned in a previous unit, it's very easy to check all of these by subbing in values for your x. Now, as we move on to our next set of examples, we're going to be using the distributive property. The distributive property says that when a number is multiplied by the sum of two numbers, the first number can be distributed to both of those numbers and multiplied by each of them separately. Then adding the products together will give the same result as multiplying the first number by the sum. Here we have 3 times 4 plus 2, which is really just 3 times 6, which we know is 18. Notice that 3 times 4 is 12, 3 times positive 2 is positive 6, and 12 plus 6 is 18. I can also use this concept to multiply larger numbers. For example, if I wanted to multiply 34 times 25, instead of setting up my multiplication grid and multiplying this out, I could also write this as 30 plus 4 times 20 plus 5. 30 times 20 is 600. 30 times 5 would be 150. 4 times 20 would be 80. And 4 times 5 would be 20. 600 plus 100 is 700, plus 150 would be 850. So 34 times 25 is 850. So sometimes there can be some confusion about when we use distributive property and when we don't. Notice that when we were multiplying monomials, there were no plus or minus signs, so we didn't have to distribute to those addition and subtractions. When we move on to monomials by polynomials, you'll notice that within the brackets there are plus and minus signs. That's going to tell us that we need to distribute. Essentially, this all goes back to order of operations. Now again, this would tell me that I need to simplify within the brackets first, but if you notice I have an x plus 1, so x cannot be combined with the 1. They're not like terms, but I can expand by distributing that 2 through. So 2 times x plus 1 would give me 2x plus 2. Moving on to the next one, I have x times x, and then x times positive 3. So that would give me x squared plus 3x. Moving on to our next two examples, I have negative 3x times 7x, so negative 21x squared. Negative 3x times negative 2y, so negative 3 times negative 2 is positive 6. X times y is xy. And then negative 3x times positive z gives me negative 3xz. Now, as I'm doing this example, I'm talking through it partly because I'm making this video, but when I do these questions myself, I also talk to myself as I do it. It helps me in a couple different ways. One, I think faster than I write, so when I'm saying it out loud, it helps to slow me down a little bit. Also, I have a tendency to miss my negatives. I don't know what it is, but unless I actually say the negative out loud, my brain doesn't register that it's there. So I might just say negative 3x times 2y, and I miss that there's a negative in front of the 2. So as you work through your practice questions, if you find that you're making those silly mistakes, either with adding or multiplying or missing a sign, definitely consider talking out loud. It's a really good tip that's worked for a lot of my students. Now, moving on to part D, here I have 4 times 2x minus 3 minus 2 times x minus 6. The 4 is going to apply to the 2x and the negative 3, and then there's a stop sign that says don't go any further. And then the negative 2 is going to apply to the x and the negative 6. Now, typically I don't write the arrows before I do the work. I find it more helpful to do it as I'm talking through, so I'm just going to erase these, and then we'll write them down as we do them. So 4 times 2x is 8x. 4 times negative 3 is negative 12. Negative 2 times x is negative 2x. And negative 2 times negative 6 is positive 12. Now I can combine like terms. So 8x minus 2x is 6x. And negative 12 plus 12 is 0. Now the next set of examples involve multiplying binomials, and this is very similar to what we did when we were working with the algebra tiles. So one way to expand these out is to use an area model or a box. Notice that I have 2 terms in the first bracket and 2 terms in the second bracket, so 2 by 2 would be my grid. Then I set up x and a positive 2, x and a negative 5, and just like I did with my algebra tiles, I can multiply this out. So x times x would be x squared. X times positive 2 is positive 2x. Negative 5 times x is negative 5x. And negative 5 times positive 2 is negative 10. Combining like terms, I would have negative 5x and positive 2x would be negative 3x. So my final product would be x squared minus 3x minus 10. Now, another way to expand this out is to use our distributive property and our arrows. So x times x would be x squared. X times negative 5 would be negative 5x. 2 times x would be positive 2x. And 2 times negative 5 would be negative 10. Once again, I'm going to combine my like terms. So that's going to give me x squared minus 3x minus 10. So let's work through some more examples. I have x times 2x is 2x squared. X times positive 1 is positive 1x. Again, you can write that 1 or not. Negative 3 times 2x is negative 6x. And negative 3 times positive 1 is negative 3. Now you'll notice that I set this one up a little bit different than the previous example, just again a different format. So 2x squared, 1 minus 6 would be negative 5x, and then negative 3. X minus 4 times x plus 2, I'm going to have x squared. X times positive 2 is positive 2x. Negative 4 times x is negative 4x. And negative 4 times positive 2 is negative 8. Again, as you're talking through this, you'll find that you make less mistakes, especially with regards to negatives. So saying those negatives out loud often helps. Here we have x squared. Positive 2 minus 4 is negative 2x. And then we have negative 8. Our last example, x times x is x squared. X times negative 4y is negative 4xy. Negative 2y times x is negative 2xy. And then negative 2y times negative 4y is positive 8y squared. Now, some of you, when you're multiplying this out, may have missed that those middle two terms were like terms. That's why it's really important to write it in algebraic order. 2xy and 2yx are the same thing because order doesn't matter with multiplying. But if I saw a negative 4xy and a positive 2yx, I may not recognize at first glance that those are like terms. So if everything is written in algebraic order, that will help. Now I have x squared minus 6xy and positive 8y squared. Now, if you remember from a previous unit, we can always check our simplified expressions using substitution. So I'm going to show you a format here using a left side, right side chart. The left side would be the x minus 4 and x plus 2, and the right side would be my simplified expression. If I sub in a value for x and they simplify to be the same number, then I know that I've done all of my work correctly. I'm going to let x equal 2. So 2 minus 4 times 2 plus 2 would give me negative 2 times positive 4, which would be negative 8. On the right-hand side, I would have 2 squared minus 2 times 2 minus 8. So 2 squared is 4, minus 4 minus 8 is going to give me negative 8. Those two give me the same value, so I can check them off. The same can be done with my calculator. If I assign a value of 2 for x minus 4 times x plus 2 would give me negative 8, and x squared minus 2x minus 8 would also give me negative 8. Now for this last set of examples, I've thrown a variety of different expressions at you. Some are going to involve a little bit more work than others. All of them are going to involve following order of operations, so brackets, exponents, and so on. You may want to pause the video, try these on your own, and then come back and check your work, or follow through as I talk through them. For part A, we have a monomial times a binomial. We're going to use the distributive property, so 2x times negative 3 is negative 6x, and 2x times 2x squared is positive 4x cubed. For part B, you might want to put a star by this question. This is one that I often see students make mistakes with. Often they want to go 5 minus 3, and that would not be correct because if you remember, we need to follow order of operations, which says that we need to divide and multiply before we add and subtract. So instead of going 5 minus 3, we need to distribute that negative 3 through the brackets. So I'm going to have 5 minus 3x squared, and then negative 3 times positive 2x is negative 6x, and then negative 3 times negative 1 is positive 3. Then combining like terms, and again keeping everything in algebraic order, I'm going to have negative 3x squared minus 6x, and then 5 plus 3 is 8. As you get more complex with your expressions, you may find it helpful to use little dots or check marks or cross out your terms as you've combined them, just so you know that you haven't missed anything. For part C, we can approach this question in two different ways. Remember that order doesn't matter when we're multiplying, so we can bring in the 3 to that first bracket, or we can multiply our two brackets and bring in the 3 afterwards. So I'm going to show you both methods. For the first one, I'm bringing in the 3. So I'm going to have 3 times 2x is 6x, and 3 times negative 4 is negative 12. I'll close my brackets and then x plus 1. Remember that that 3 stops coming through when I hit my stop sign. Now I can multiply out. 6x times x is 6x squared. 6x times positive 1 is positive 6x. Negative 12 times x is negative 12x. And negative 12 times 1 is negative 12. Combining like terms, I'm going to have 6x squared minus 6x and then minus 12. Now the other way to do this question is to multiply our brackets first. So we're just going to have the 3. 2x times x is 2x squared. 2x times 1 is positive 2x. Negative 4x and negative 4. Combining like terms, I'm going to have 2x squared minus 2x minus 4. And then distributing the 3 through, I'm going to have 3 times 2x squared is 6x squared. 3 times negative 2x is negative 6x. And 3 times negative 4 is negative 12. X minus 3 minus 2x plus 1. That means that that negative needs to distribute to the 2x and to the 1. Some people will find it helpful to actually put a 1 there and then distribute with the arrows. Others will just talk through the example. So I'm going to have x minus 3 minus 2x minus 1. So that's me distributing that negative 1 through. And then I can combine like terms. So x minus 2x is negative x. And negative 3 minus 1 is negative 4. Again, another way is just to talk through this example. So x minus 2x is negative x. And negative 3 minus 1 is negative 4. Part E, you'll notice that I have a trinomial times a trinomial. So 3 terms times 3 terms, which means when this is expanded out, I'm going to have 9 terms, and then I will simplify by combining like terms. When we're working with that many terms, it's going to be important that we are as organized as possible, and we're always checking for little mistakes like multiplying or adding errors or missing a negative. So again, talking to yourself as you do these will be very helpful. We have 2x squared times negative 6x squared, which gives me negative 12x to the 4th. 2x squared times negative 4x is negative 8x cubed. And then 2x squared times 1 is positive 2x squared. As I distribute the second term, you're going to notice that I move to the second row. And again, I'm going to be lining up my like terms. So 3x times negative 6x squared is negative 18x cubed. 3x times negative 4x is negative 12x squared. And 3x times 1 is positive 3x. Then for the third term, I'm going to have negative 5 times negative 6x squared is positive 30x squared. Negative 5 times negative 4x is positive 20x. And then negative 5 times positive 1 is negative 5. So as I combine my like terms, I'm going to have negative 12x to the 4th. Negative 8 minus 18 is negative 26x cubed. Notice again, my variables are not changing now that I'm adding and subtracting. I have 30 minus 12 is 18, plus 2 is 20. So I'll have 20x squared. 3 plus 20 is 23x, and negative 5. For our final example, we have 2x plus 5 squared times 4x minus 1. That means 2x plus 5 times 2x plus 5, and then 4x minus 1. What often happens is students want to just bring that 2 in. We can't because of the plus sign. Remember that if I had 3x all squared, that means 3x times 3x. So if I have 2 terms and I'm squaring them, I should end up with 4 terms before I simplify. If I just bring in that 2, I'm going to lose a term. So multiplying this out, I have 2x times 2x is 4x squared. 2x times 5 is positive 10x. 5 times 2x is positive 10x. And 5 times 5 is positive 25. And then we're still being multiplied by 4x minus 1. Simplifying within the brackets, I have 4x squared plus 20x plus 25, and then 4x minus 1. Now notice here I have 3 terms times 2 terms, so that means when I multiply this out, I'm going to have 6 terms. You'll notice as I do this one, just to save space, I'm not using my arrows, but I'm still going to talk through term by term. So 4x squared times 4x is 16x cubed. 4x squared times negative 1 is negative 4x squared. 20x times 4x is 80x squared. 20x times negative 1 is negative 20x. 25 times 4x is positive 100x. And 25 times negative 1 is negative 25. Now again, I'm looking for common terms. So I have 16x cubed. Negative 4x squared plus 80x squared is 76x squared. Negative 20x plus 100x is positive 80x. And then I have negative 25. Now, when it comes to expanding polynomials, there are so many different examples that you can come across, way more than I can show you here. The best way to get proficient with these is just to practice, practice, practice. Remember some of those tips that I gave you. Talk out loud, draw your arrows as you're distributing, really pay attention to your positive and negative signs, and you can always check your work using substitution. All right, that's all I have for you today. Have a great day, and I'll see you next time.